All right, geometry, here we go back, continuing our work on standard 5. So again, a reminder of the standard scale for us here. Okay, so you are considered to be at the beginning level if you can identify the appropriate criteria for congruent triangles within the context of a proof. You're at the approaching level of 2 if you can construct a 2-column proof for congruent triangles using given information and one or more of the following, which consists of vertical angles, reflexive property, and right angles. Okay, and then you're considered proficient at level 3 if you can construct a 2-column proof for congruent parts of congruent triangles using given information and one or more of the following 4. Okay, and those 4 include midpoint, angular segment bisector, perpendicular lines, and isosceles triangles. Okay, and then you're considered to be at exemplary or level 4 if you can construct a 2-column proof for a midpoint, angle bisector, segment bisector, or isosceles triangles using CPCTC. We haven't gotten to that yet, but we will. Okay, so today we are working on our in class 21. Okay, in class 21. So I got to zoom this out a bit so we can see more. Okay, so in class 21, constructing proofs for congruent triangles using the flowchart format. Okay, so I can zoom a little bit more here. So first of all, let's start by circling whether each reason would accompany congruent sides and or congruent angles when applied correctly. Okay, so would the definition of midpoint apply to sides or angles? Midpoint deals with the sides, right? Okay, would the definition of angle bisector work with our sides or our angles? That deals with angles, right? If it intersects at the in the middle of the angle. The right angles theorem? Yep, you got it. That affects the angles. And the reflexive property can affect sides and angles. Okay, so just a little review there, reminder. Okay, so let's look at our first practice proof here. Okay, so to start with, we're given R is the midpoint of QT and angle U is congruent to angle S. Okay, I tend to always start with the first one. R is the midpoint of QT. So I mark on my diagram what that tells me. Okay, I start by my given here. R is midpoint of segment QT. Okay, that's given to me. Now, what is it that we know because of that? Okay, because of that, we know that segment QR is congruent to segment TR. Okay, and what's the reason? That would be our definition of midpoint. Okay, so kind of once you jump down here, you keep going. Okay, so I am also given that angle U is congruent to angle S. Okay, and that's given to me. Okay, what else do we know about this triangle given our diagram here? We have vertical angles, right? So our vertical angles theorem says that angle QRU, so QRU is congruent to angle TRS, okay? Again, order matters. So I went from Q to R on my first congruent side. So I have to go from T to R. See that? So that when I look at here, this says QR is congruent to TR, which is true. Okay, so what conclusion do I have from that? Well, remember what you're trying to prove. That's what your end result needs to be. So triangle RQU is congruent to triangle RTS. And why is that? angle, angle, side, angle, angle, side. Just completed your first flowchart format proof. Okay, our second example. Okay, we are given that OM bisects LMN. So ON bisects LMN. So I'm going to draw on here what that tells me. It tells me these two angles are congruent. Okay, I'm also given that angle LOM is congruent to angle NOM. But I'm going to do one thing at a time. Since I'm told OM bisects LMN and that gives me something, I'm going to write that down for my proof. OM bisects angle LMN is given to me. Okay, and because of that, what do we see happens? Well, we see angle LMO is congruent to angle and LMO is congruent to angle NMO. Okay, and the reason for that is the definition of angle bisector. Okay, so again, once I'm down here, I'm going to stay down here. So the next thing I'm given is LOM. LOM is congruent to NOM. LON congruent to NOM. Okay. Reason? Because it was given to me. Okay. So at that point, that's everything that's given and what I can get based on what's given to me. So what else do I see in the diagram that can be included? We can say that segment MO is congruent to segment, say, MO. Okay, reason for that? That's our reflexive property. Shares the same. Okay, so because of that, what do I have? I have angle, side, angle, angle, side, angle. So because of angle, side, angle, I have proven what it's asked me to prove, which is that triangle LMO is congruent to triangle NMO. So see, when you break it down and do one step at a time, you will be just fine. Okay, so flip the page for our last two proofs for the in class 21 lesson here. Okay, I'm going to zoom out a little bit so I can keep the whole thing in here. Okay, so K is the midpoint of JL, segment JL, okay, and I'm given angle JKM and angle LKM are right angles. Okay, so I'm trying to prove that triangle JKM is congruent to LKM. Okay, so let's go ahead and start with what's given. K is midpoint of JL. K is the midpoint of JL, so I'm going to mark on there. Okay, that was given to me, and because that was given to me, what can I find? What do I know from that? Okay, well, I know that segment JK is congruent to segment LK. Okay, and that is because of my definition of midpoint. Okay, so then again, I'm down here, so I'm going to stay down here. I don't go jump back up, right? Follow your arrows. Okay, I'm also given that angle JKM is, and LKM are right angles. So that means they are congruent. And the reason is my right angles theorem. Okay. So I've taken care of everything that's been given to me, and what else do I see that I know from the diagram given to me? That KM is congruent to Km, and that is my reflexive property. Okay. So based on that, now I have all three parts: side, angle, side, side, angle, side. I forgot I didn't need it to make those two congruent because it's not the same as these, right? But I have side, angle, side, which tells me that the triangles are congruent. So I can verify the proof. It says that triangle JKM is congruent to triangle LKM with the criteria of side, angle, side. Okay, great work. One last one before you are off to do homework 21. Okay, so we're given that segment RT bisects angle URS, and that triangle URS is isosceles with a base at segment US, and we're asked to prove that triangle URT is congruent to triangle SRT. Okay, so if we start with the first one given to us, we are told RT bisects angle URS, which is given. So if RT bisects angle URS, that tells us that to make equal angles. So I can say that angle SRT is congruent to angle URT based on the definition of angle bisector. Okay. Next, I'm given that URS is isosceles with a base of US, okay, which says that RU is congruent to RS because it is our definition of isosceles triangles. Isosceles triangles, that's a little triangle I abbreviated. Okay, and what else do I see in my diagram that I know? I know RT is congruent to RT, and why is that? Segment RT is congruent to segment RT. Reason is reflexive property. Okay, so I have now three parts: side, angle, side, side, angle, side. So I can say that triangle URT, as the proof has, is congruent to triangle SRT, with the criteria being met for side, angle, side. And that is our last example for in class. That means you can now go ahead and complete homework 21.